Hi, my name is Michael Benben. I am in Challenge 2016 in Math 2000, and this is my first bonus interactive learning video, and I'll be doing number 81 from chapter 10.1 because my student number ends in an odd number. So in this problem, we're asked to find whether a sub n, which in this case is the inverse tangent of n, converges or not. And if it does converge, we have to find its limit. So in order to do this, we're going to be using a power series, and then we're going to try to find a limit to the series to the power series of this a sub n. And if we can find that limit, then that means that we can find an interval convergence, which shows that this equation converges or not. So we're going to begin this process by first finding the power series of the inverse tangent of n, and then from there we can find the limit. Alright, so now in order to find the power series of the inverse tangent of n, we need to use Taylor series. And we're going to be doing a Taylor series to the third degree in order to find the power series. So this will be enough to help us see a pattern. So first of all, we have the original equation, f of x, arctangent of x, which is the same as inverse tan of n. And then as we derive it, we have the different formulas needed to solve the Taylor series. So then, since it is a Taylor series, the inverse tangent of n is centered at 0. So we plug in 0 for each one of these, and we get 0, 1, 0, and negative 2. And this will be enough to help us start seeing a pattern in the outcomes of the series that we're trying to find. So we can derive this series and use it to find the limit of this problem and see if it converges or not. As we continue through the Taylor series, we can find that this is the equation that we're going to have. So we end up with x minus x cubed over 3. And if we were to continue going through the Taylor series, we would continue to see a pattern very similar to this. So this pattern shows us that the power series for the inverse tangent of n is the summation from n equals 0 to infinity of negative 1 to the power of n times x power of 2n plus 1 over 2n plus 1. So using this, we can now move on by using the ratio test to find whether or not the inverse tangent of n converges or not, and that will help us also see what the limit is. Okay, now that we can apply the ratio test, we can take the original equation and add 1 to wherever n is, and then multiply that by its reciprocal without adding n. So then we need to start reducing this. So we can see that negative 1 to the power of n plus 1 and negative 1 to the n, we can cross out the powers of n. And when we multiply out this area right here where 2 times n plus 1 is, we see that it's 2n plus 1 plus 2. So then when we go on to the next section, we can split up x as x to the power of 2n plus 1 and x squared. And then with that we can cross out the x's. So let me cross out some of these so we can see what's happening here. So in the first spot, that gets crossed out, that gets crossed out, and then the second part we cross this and this out. So as you can see here, I erased the power of n that negative 1 was at, because it was canceled out by the negative 1 to the power of n down here. And the second part, the x to the power of 2n plus 1 from the numerator here was canceled out by the same portion down here in the denominator. So now when we multiply this all out, we end up getting this here. Also, this negative 1 cancels out because since it is an absolute value, we won't end up having a negative number in the fraction, so we don't need that there. So in the end, we have the limit as n approaches infinity of the absolute value of x squared times 2n plus 1 over 2n plus 3. And now evaluating this limit, we see that the answer to that will just be the absolute value of x squared. And since we have this, we can find the interval convergence for the arctangent of n. So by being able to find interval convergence, which in this case is negative 1 is less than or equal to x is less than or equal to 1, we can say that the whole equation is convergent. In addition, just to sum everything up, When we had a sub n is equal to the arctangent of n, we found that the power series was sigma n equals 0 to infinity of -1 to the power of n times x to the power of 2n plus 1 over 2n plus 1. And by using that in the ratio test, we were able to find the interval of convergence, which is -1 to 1 inclusive, and we could determine that a sub n tangent to the power of -1 n, which is arctangent, is convergent.